thank everyone for coming today. Lori McConnell and Steve Lorenzetti of the National Park Service for giving us this generous opportunity to present here at the Lincoln Memorial today. I'd like to thank Blaine Cliver, Historic American Building Survey, for their support of the Parthenon project and their willingness to come and share with us their experience in documenting historic buildings. I'd like to thank Mary Kafori from the Smithsonian Institute for their work at presenting America's historic heritage and cultural resources in such sensitive and diverse settings. We're very lucky to have in-house here today 3 institutions that work and are dedicated to maintaining, documenting, and presenting America's cultural resources. 2 years ago, my wife and I were on our honeymoon. At least she was on our honeymoon. She gave me the wonderful opportunity to take a little architectural pilgrimage up to the Parthenon. And I had a good fortune to meet an architect who was working on the restoration that they are currently involved with. And while we were talking, she was telling me about the 3-dimensional puzzle they have of trying to rebuild the cellar walls. As she was telling me about this, my experience with architecture, with computers, with graphical databases, and I realized there's a real opportunity here to contribute to the reconstruction of the Parthenon. This is a drawing by Dr. Manolis Caress. It's one of the many 3D axonometrics he's drawn of the existing temple. What we're talking about today is about creating fully dimensioned, 3-dimensional objects, being able to study them, being able to work with them, being able to convert them from their raw data into plans, sections, elevations, but working within that sort of realm of 3D. I'd like to introduce my team. Myself, I'm an architect and principal investigator. My role on the projects is to do the research, to understand the architectural implications, to develop criteria for the modeling that we produce, and to integrate the process through to the final models that are used for scientific and educational uses. I'd like to introduce Chris Korkalo. He's the lead systems engineer with Spatial Integrated Systems. He has a vast experience with the laser scanners that you're looking at today. He'll tell you about the planning that goes into spatial documentation, development of the plan of action for the scan, performing the scan, and then the registration afterwards. He'll go into more detail then. Michael Raphael here is chief engineer and president of Direct Dimensions. He was one of the earlier developers of a tool called the Pharaoh. It's used throughout aerospace and automotive industries as a tool for reverse engineering. His work is primarily after the scanning work. He does do a lot of the planning, coordination, moving into a project, but he takes over from the data that Chris has produced to develop those final models. Without further ado, I'd like to introduce Chris.
All right, thank you, Scott. First step in a spatial modeling project is the planning phase. This involves discussions amongst the team to determine 3 things. The first is the scope of work, the second, level of detail, and the third is the purpose of that documentation. Our scope of work being these 4 columns. We chose 2 locations exterior, shooting in. We chose 2 locations interior, shooting out. The second item is level of detail. We typically use 3 different levels of detail for capturing architectural data. The first being what we call the base detail, and that's at approximately 1 point every 40 millimeters. The second level of detail, what we call medium level of detail, is about 1 point every 8 millimeters. And then the third level of detail, the high level, is about 1 point every millimeter. The next step is purpose. The purpose we've defined for this demonstration is to compare the existing conditions of these 4 columns in the surrounding area with the equipment, tools that we're using, as compared to the existing computer-aided design drawings that exist in this area today. The laser scanner is hooked up to the laptop. It's a line of sight. We pointed it in this direction. We are looking at the top half of the 4 columns. After some minor preparation, simple press of a start, after setting some of the parameters, we'll start the scanning process. This is set the field of view of the scan of what I want to capture. What we do is take each scan and do a little cleanup. We'll go out and fence in any data that was captured with people walking by to clean those scans up. That same concept can be applied to scaffolding or stanchions, ropes, trash cans, anything that might be within the site. The second stage involves registration, and that's putting together the different scans into the same 3D space. A good analogy is taking a series of panoramic photographs from now is turn this over to Michael Raphael, who will continue the discussion.
Scott, thank you for coming. We are a local engineering resource that Scott found several years ago as he talked about his passion to recreate and capture the essence of the Parthenon in full 3D. We helped him perform some of these tasks using some of the technology that we work with, and some of which we've developed. The Leonardo da Vinci horse that was created in the Middle Ages. The horse was sculpted, it was destroyed. The sketches remained and were more recently found. An artist to recreate the sculpture as best as able. We utilize some of our technology to capture the three-dimensional shape of the sculpture to create a detailed model of the surfaces. Some areas, as you can see, as Chris was pointing out earlier, higher resolution based on the level of detail, for example, in the mane, the tail, the face, and then low resolution where it's required. This is a 12-foot piece that was created by a local artist in Georgetown. We were utilized to scan the original 12-foot sculpture. This would be an example of the process that we're describing, where we take the cloud of points, polygonize it, or create that triangular mesh of points. In this case, we took it through to a complete mathematical surface model, and the point of that is to take out all of the faceting that you would see in a typical model, the highest accuracy surface model that one could create. Any of this information, once this is captured into the computer, can be sectioned in any direction, in any manner one wishes, to create section cuts such that they can be used as two-dimensional vector drawings for documentation purposes.
Thank the National Park Service for the generosity of letting us present here today. Documentation, whether or not we're in maintenance or conservation, or in the case of the Parthenon, reconstructing. That data that's three-dimensional can be sliced and made into two-dimensional lines that are line work that can be used for architecture, engineering, and construction.
Fellow citizens, we cannot escape history.